Alright, last video of the week. A59, I'm going to do, I think, what number is this that I'm doing? Number 5. So I'm doing number 5. Alright, so it's y is equal to negative x minus 3. So I'm going to go ahead and graph the blue one here. So in this case, it's already in slope-intercept form because y is isolated. So my y-intercept is negative 3. So let's go to 1, 2, 3. There it is, negative 3. And now my slope, which is my change in y over my change in x, is equal to negative 1, right? Because negative 1 times x gives us negative 1. So I have negative 1 over 1. Therefore, my change in y is negative 1. My change in x is positive 1, negative 1, positive 1, negative 1, positive 1, negative 1, positive 1. And there is my line. Now, if I come over here and I do my red line, I'm in y-intercept form as well because my y is isolated. My y-intercept is equal to negative 8. So I'll go down here. There's negative 8. And my slope is the change in y over the change in x, and that's equal to negative 2, which I'll write as negative 2 over 1. And now I know I go down 2 and over 1. So down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1, let's see, down 2 over 1, so I have my line coming here. Let's go ahead and extend our blue line and see what happens here, see if I can pick up the intersection point. And then this comes, and I'm going to go through, they're going to intersect, let's see here, right here. So let's go ahead and, why didn't that work? Here, so I have that point right there, and that's going to be 1, 2, 3, 4, 5. It's going to be negative 5, comma, and then up 2. So that point where they intersect looks like it's negative 5, 2. And let's go ahead and verify that by plugging it into the equation. So let's start with the blue equation, because we graphed it first, and I have y is equal to negative x minus 3. And into that equation, I'm going to plug the point negative 5, 2, and make sure it is in fact a point on the line. So that's going to give me my y is 2, 2 is equal to the opposite of negative 5. Come on. Minus 3. Okay, so that's going to give me 2 is equal to, and then I have the opposite of the opposite, right? So once again, that means I get to go plus, plus. So I end up with a positive 5, and then I have minus 3. Well, sure enough, if I do that, I get 2 is equal to 2. Therefore, I know the point negative 5, 2 lies on that graph. Okay, now let's take a look at the other one. So, which gives me y is equal to negative 2x minus 8. So, I'm going to plug that point in again, and that's going to give me 5 is equal to negative 2. And now I'm going to have times negative 5 minus 8. And that's going to give me 5 is equal to negative 2 times negative 5 gives me a positive 10 minus Oh, shoot. I made a mistake. Here, let me go. Shooters. Let's see here. I plugged in 5 when I should have plugged in 2 for my Y, so let's go ahead and make that correction. There we go. So I get Y was 2. See, Y is 2 there, and I just plugged in the wrong point. So I have 10 minus 8, and that sure enough gives me 2 is equal to 2, and that checks, and it fits. It passes through the point negative 5, 2, and that in fact is the intersection point there. All right, so now I'm going to do number 35, which says, I want to say if there's one solution, no solution, or infinitely many solutions. So in order to do that, this time I'm not going to graph these. I'm going to go ahead and do this by looking at my slope and my y-intercept. So in this case here, in the first equation, which is green, I know that my slope is equal to 2/3, and I know my y-intercept is equal to 4. And now, if I take a look at the red one, I can see that, it's not in slope-intercept form, so I have to make that happen. So I have to isolate y, so the first thing I'm going to do is subtract 2x from both sides. And when I do that, I end up with, that's gone, negative 3y is equal to, and once again, you guys, I'm just going to write my negative 2x first, just because that looks nicer. So negative 3y is equal to negative 2x plus 3. I still haven't isolated y. Y is being multiplied by negative 3. So to get rid of that negative 3, I'm going to divide every single term by a negative 3. And that's going to give me y is equal to, because negative 3 over negative 3 is 1. 1 times y is just y, is equal to, well, negative 2 over negative 3 is a positive 2/3 x, and then a positive 3 divided by negative 3 gives me minus 1. So in this case, my slope is equal to 2/3, and my y-intercept is equal to 1. Okay? So I can see that they both have the same slope, but they have it's not a good choice in colors. Let's see, I'll go with yellow. But they have a different y-intercept. Therefore, they're not the same line because they have a different y-intercept. But since they have the same slope and different y-intercepts, the lines are parallel. Okay, and there is no solution. Those two parallel lines will never intersect, and therefore there is no solution. All right, last problem I'm going to do for the week. So number 36, it's y is equal to negative x minus 3 is the black line, and negative y is equal to x plus 3 for the red line. So this one is already in slope-intercept form since y is isolated, and once again I can say that's equal to, y is equal to negative 1x minus 3, since negative 1 times x gives me my negative x. All right, so now my slope I see is negative 1, and my y-intercept, come on, is equal to negative 3. So let's just quickly go ahead and do a quick graph of this. So, 1, 2, 3. There's my y-intercept at intersect at negative 3, and my slope is negative 1. So I'm going to go down 1 over 1. I'm going to go down 1 over 1. I'm going to go down 1 over 1, and there's my line. Right? You can see. Right, negative slope, a slope of negative 1, and a y-intercept of negative 3. So in the red line here, I'm close to being in intercept form, but not quite because there's a negative on the y. So I'm going to write this as negative 1y, because negative y, 1 times y gives me negative y, is equal to 1x, because 1 times x is x, plus 3. And now I need to divide everybody by negative 1 to get y all by its lonesome. And that's, negative 1 over negative 1 is 1, and that leaves me with just y over here. 1 over negative 1 is negative 1, so I have negative 1 times x. And then 3 divided by negative 1 is a negative 3. So I come graph this, I'm at negative 3, there's my y-intercept. So my y-intercept here is negative 3, and my slope is negative 1. So this says, right, down 1 over 1, down 1 over 1, down 1 over 1. There's my slope, and you can see that they're an identical line. All right, so if I think about this, guys, right, so they have these two, right, they have the same slope of negative 1, so they have the same slope, right? And, cool, let's see, I'll do green. They have the same y-intercept, negative 3. So they have the same y-intercept. Therefore, they must be the same line. Okay? In fact, we say in this case that it has infinitely many solutions, and we write those solutions as every xy pair such that y is equal to negative x minus 3. Oops, that negative x didn't exactly show up. Okay? In fact, if we come back here, right, and we look, we can see that both of them are the same equation. Y is equal to negative 1x minus 3. Alright, that's it for my video. You guys, make sure you do some review for your quiz tomorrow. Alright, guys, I will see you soon. Little heart and another little heart. Bye.